Welcome to the midweek Space Startup News Roundup. So I'm going to go over some interesting space news I saw this week. Starting first with Nord Stream. Nord Stream is a Canadian space startup that's working on rocket vehicles. They have a Tiger suborbital vehicle, and then later on they're working on a Tundra orbital launch vehicle. So they're attempting to launch Tiger from their own spaceport in Canada. They're targeting the 24th of September, that's Wednesday. The launch window opens at 6:30 a.m. NDT and 70% probability of favorable weather conditions. So they had a pad anomaly last night. Some fuel was satellite. That's been fixed. The launch pad is cleared. The vehicle is secure, so they're going to try it again today. So hopefully today they'll manage to get the vehicle flying. It's the very first time, so I don't think it's going to fly very high. It's not a full load of fuel. It's just to test out whether they can launch successfully, and I'm sure they'll have a number of these launches, and hopefully it will go higher and higher. And this is just validating guidance control, ground support, and so on with the vehicle. So it will help them with their Tundra orbital vehicle, which they're also working on. So moving on, we have a story on Bluefors, which is a new company that I'm not aware of. But they're sourcing helium-3 from the moon. They signed an agreement with Interlune for quite large amounts of helium-3. So Interlune, I did a video on 6 months ago. So they're working on harvesting helium-3 from the moon's regolith and then sending it back to Earth for sale. And also Magna Petra is also working on the same idea. So there's two videos I've done on those companies. Interlune have managed to get a number of contracts. They have a contract with the Department of Energy, the US Department of Energy. They also have a contract with Maybell Quantum. So that's a private contract to source helium-3. And now they have another private contract with Bluefors. So Bluefors describes itself as a leading manufacturer of dilution refrigerators, which are needed for quantum computers. Quantum computers have to be cooled down to absolute zero or as close as possible for them to work. Any kind of thermal heat or energy will destroy the calculations. So you need very specialized refrigeration equipment. For that, you need helium-3. The only problem is you can't get helium-3 from Earth, or it's very, very scarce and therefore extremely expensive. It is, however, quite relatively abundant on the moon. So Interlune and Magna Petra are working on harvesting that helium-3 and sending it back to Earth for sale. It's a purchase agreement for up to 10,000 litres of helium-3 annually for delivery from 2028 to 2037. The Bluefors founder and CEO Rob Blauberg says, Interlune will provide huge amounts of helium-3 that the quantum industry needs in the coming years to drive innovation, commercialization, and progress forward. Sourcing abundant helium-3 from the moon helps Bluefors build cooling technologies that will unlock the potential of quantum computing even further. The quantum future is built on Bluefors cooling technology, and Interlune is now a vital partner in that future. There's only one possible resource on the moon that is financially viable to return to Earth, and that's helium-3. Everything else is useful on the moon, but you can't make money shipping it back to Earth. So it's interesting that Interlune has got now 2 commercial contracts and a contract with the US Department of Energy. So there's definitely demand for helium-3. So keep on top of this story, because potentially this is private companies contracting with other private companies for resources harvested off-world. So I find that very interesting. Stoke Space pad update. I think I have a few photos here somewhere. Yeah, here they are. So Stoke Space is working on an orbital vehicle called Nova, and the vehicle is fully 100% reusable. So the first stage and the second stage are fully reusable, both return back to the pad. It has a lot of new technology. The second stage has an active metal shield cooling system. It has an aerospike engine, and of course it's fully reusable. So they're working very hard on the pad. You can see here's the flame trench, the flame diverter. So they put a few photos on social media on the X platform. They built this pad in about a year, so extremely quickly for a vehicle of this size. It's I think it's Silic 14 at Cape Canaveral, so it's a great location, and hopefully they will be launching next year. I think that's the plan at the moment, 2026, so that's very exciting. There's a European space startup company that I've not covered directly. It's called Space Cargo Unlimited. They secured 27.5 million euros for their BentoBox payload platform. So they're working on a re-entry system called Rev1. They're partnering with Thales Alenia Space in Italy to develop a returnable space platform called Rev1, which is designed to support in-orbit manufacturing and microgravity experimentation. So it's the ISAM market again, the in-space assembly and manufacturing sector, which is growing all the time. I did a video on that yesterday for metal foundries in space. It's all part of ISAM. So they're working to provide this modular payload platform, which they're calling BentoBox, and it'll support up to 100 kilos of customer payloads. And those payloads will then be returned in the Rev1 cargo bay. So you go to space, you manufacture or do whatever you want in those microgravity conditions, and then the system will return back to Earth and you can retrieve your cargo. You know, whether you're making crystals or pharmaceuticals or bio-life science, whatever it is. So there's a number of these companies now working on that kind of system. Vada Space and Atmos space cargo as well. I guess Dream Chaser vehicle is also included in that sector as well. So they say that to begin with, the BentoBox will be offered as a standalone platform. And they partnered with Atmos Space Cargo, that's a German space startup, to return the capsule using their inflatable heat shield technology. So the initial flight of the BentoBox payload platform is expected to take place in the second quarter of 2026. They've also, in addition to the 27.5 million euros, they 2 months ago received 12.5 million euros, so that's 40 million euros recently, via European Innovation Programme. That supports the development of the BentoBox platform, and they have a partnership with Atmos for 7 missions scheduled to occur between 2026 and 2027. So that's a high cadence. That's how many? 7 missions in just 12 months, and that's part of the Atmos inflatable heat shield technology. So keep an eye on that. Atmos, by the way, has already flown once on a transporter mission. It was partially successful. It managed to inflate. It came through the atmosphere, but they lost communication with it. So that was a tech demo. So they're refining the technology, and hopefully they'll manage to get it to work. And they're already partnering with other space startups to provide an end-to-end service, which is fantastic. And moving on to the next topic, which is Starcatcher. I've covered Starcatcher in a video quite a while ago now, but basically it's collecting solar power from the sun, storing it in batteries, and then beaming it to other satellites. So it's not beaming it down to Earth, it's a satellite-to-satellite network. So this will provide extra power to satellites, either to run their equipment at higher power or to have it run 24/7. So sometimes the satellite's in the shadow of the Earth, so it doesn't get solar power. So either you have to make your systems dormant, or you have to use batteries, which are expensive and heavy. So with the Starcatcher system, it will beam power directly onto the solar panels of client satellites, keeping them powered 24/7. So they had this flyer, this banner they put on their X account, which talks about powering up very low Earth orbit satellites. The advantage of being very low in the atmosphere, so this is less than 250 kilometers, is Earth observation works better because you're closer to the target. Communication is faster, there's less latency. The only issue is you encounter more atmosphere, so you need more thrust to stay in orbit. More thrust means more power means more solar panels, which means more drag. So you've got this catch-22. It's quite difficult to stay in orbit. So one way to cut through that catch-22 situation is Starcatcher can beam the power down to the satellites, so they don't need more solar panels or batteries. They can just have the power beamed down to them. So this is a great use of the Starcatcher network system. They say that for very low Earth orbit, and they're talking below 450 kilometers and really below 250 kilometers, it's quite difficult to stay in the orbit because of the drag caused by the atmosphere. So they say that their system, with solar powered beamed from the Starcatcher network, the first power grid in space, VLEO satellites can generate between 2 and 10 times more power without needing more solar panels. And this transforms VLEO from the edge of possibility to operational reality, is what they're saying. They're saying, you can keep that satellite in orbit for long enough that it pays for itself. It's commercially viable. So let me move on to Blue Origin. There's quite a bit I want to say. First of all, they won the Viper contract. We'll start with this, show you the video, the photo first. So this is Blue Origin Mark 1 lunar lander. This is a cargo lander, and it can land three tons of cargo to the moon's surface. And a demo mission is coming up soon, maybe by the end of this year or next year. Here is the Viper payload. So this is a very expensive piece of equipment, this rover. I think it's like $600 million. It got cancelled because it kind of overrun its budget, even though it was finished. So they cancelled it, NASA. They tried to get a free ride. They couldn't get a free ride. So now they've decided to pay $190 million to Blue Origin for their lunar lander to put the Viper rover onto the surface of the moon. So NASA said they've awarded a Blue Origin CLPS, that's Commercial Lunar Payload Services, a task order with the option to deliver a rover to the moon's South Pole region. NASA's Viper, which stands for the Volatiles Investigating Polar Exploration Rover, will search for volatile resources such as ice on the lunar surface and collect science data to support future exploration at the moon and Mars. There it is, and we have a reaction from David Limp, who's the CEO of Blue Origin, and he said he's looking forward to partnering with NASA to prepare Viper for flight on our second Mark 1 lunar lander. The first flight will be a demo mission required by NASA. Viper is incredibly important, including instruments to help search for resources like ice. This includes our Honeybee Robotics Trident drill, designed to penetrate up to 3 feet or 1 meter below the lunar surface. Weighing about 44 pounds or 20 kilos, the drill uses a jackhammer mode to cut through hard rocks and cryogenic ice. So that drill and drilling down 1 meter is really important because the indications are that the lunar water ice is not on the surface, it's not the topsoil. You have to drill down to 1 meter or more before you get a good yield of water ice. I think the yields may be like 9%, 5 to 9%, but in the surface you get very little. So you do need a drill and you do need to excavate below the surface to find the water ice. So that's very interesting, but there's more news on Blue Origin. Just before I go into the other news, here's a graphic I did for one of my videos. So there are actually 2 lunar landers from Blue Origin. The Mark 1, which will take the Viper rover to the moon, and this is a cargo lander, and then the Mark 2 is a human crewed lander. So astronauts will use the Mark 2 to land on the surface of the moon, and it can take 20 tons in reusable mode and 30 tons in expendable mode. So it can be refueled by hydrogen and oxygen. So if you source those fuels, those propellants on the moon's surface, you can refuel the Mark II and just use it as many times as you like, which is fantastic. So the second thing I want to talk about on Blue Origin is Blue Alchemist. This is a team within Blue Origin that's working on in situ resource utilization. So using the resources, local resources on the moon and later on Mars to make propellant, oxygen, metals. So you don't need Earth supply missions or as many. You want to source as many materials and resources from the moon as you can. So they've hit a milestone with their system. So this is a render of them generating solar panels from local regolith. The moon has a lot of silicon, so if you can extract pure quantities of silicon, you can make solar panels, and here's their system doing that. And that's the team, the Blue Alchemist team. Here is a molten lunar regolith, or simulated lunar regolith. They've melted it and extracted various different materials. So there's iron, there's silicon, and there's glasses and ceramics that have been extracted from the simulated lunar regolith. So the way they do this, they just melt the regolith, and then you get volatiles, you get oxygen, and other gases. So you can trap those gases, and you can get oxygen from them. Some other volatiles, maybe nitrogen, helium, and so on. And what you're left with is metals or ceramics. So that's the idea. It requires a lot of energy, but it's quite simple in concept. You just heat the lunar soil. So they've announced that they passed a critical design review, which means they're now ready to convert it into some kind of system that can fly, either in space, the International Space Station, or hopefully on a lunar lander, so they can actually try it with real lunar soil and see if they can extract oxygen. I think at first they're concentrating on oxygen, but later on you can get metals, aluminium, iron, titanium, and various other materials. And there's even more information on Blue Origin. So they're working on a Cislunar Transporter with a fuel shuttle that stores liquid hydrogen and liquid oxygen. So to keep it cool, they need a heat shield. And you can see them testing out the heat shield now. This will block the heat and the light from the sun, keeping the propellants very cold so they don't boil off. So they've made progress on the lunar landers. They're making progress on the Cislunar Transporter. They're making progress on the in-situ resource utilization. So Blue Origin are doing very well at the moment. And there's more stuff I want to, So this is Anna Menon. She's been selected as a NASA astronaut. But the interesting thing is she's already flown on space. She flew on the Polaris Dawn mission. And she actually went further in space than any woman has ever, I think. At least for a few years until NASA lands a woman on the moon. But so she's already got a lot of experience in space on the Crew Dragon. She also works at SpaceX. Toby Lee just said, wow, for the first time, a new selected NASA astronaut candidate has already flown to orbit. Anna Menon, a former SpaceX engineer who flew on the Polaris Dawn mission, was selected to be one of the next moonwalkers as one of the newest NASA astronauts. Congrats, Anna. So that's amazing. One other animation I saw, and this is relevant to my video yesterday on metal foundries in space, I can just play that, is I said there's quite a lot of asteroids that come quite near Earth. So this is just 9 asteroids flying near Earth very recently, I think. And as you can see there's lots of them. So 2025 SX1 and so on. And so the idea is if you could capture one of those and put it into a stable orbit around Earth, you could then extract useful metals or resources from it. And there's another one that I almost included in the video yesterday, but I didn't. And this is 2024 PT5. This was an asteroid circling the sun. It came very close to the Earth and was captured by the Earth-Moon system. Occasionally, asteroids get captured. And as you can see, it's still captured. It spent 58 days in the Earth-Moon system before it eventually managed to escape. But there are occasionally asteroids that do wander near the Earth. They're circling the sun, they're in a heliocentric orbit, but occasionally if they get too close to the Earth, they get captured for a short period of time, several months. So if you could capture one of those and put it in a more stable orbit, you could extract useful materials and metals from it, which I thought was quite interesting. I didn't include that video in my Metal Foundry video yesterday, but there it is. And there's one more thing I want to talk about, and that is 3I Atlas. This is an interstellar comet. You can see here, it goes quite close to Mars, not near Earth, and then it goes quite close to Jupiter. So NASA has an information page. I linked to it in the video description, and that tells you all about the 3I Atlas. which is an interstellar comet. It's no threat to Earth. It doesn't go near Earth, but it's very interesting because it's interstellar. But there are links to an information page. Also a link to like a NASA visualization tool, so you can see exactly where the comet is, and you can see when it's going to intercept or get close to Mars, and then later on Jupiter. That's me finished for today. So I've done a video already this week on metal foundries, and I'll be doing another video next couple of days on another lunar infrastructure video. And I do live streams every weekend, and I go over my videos. I bring up comments. People leave good comments, interesting comments, thoughts and opinions. I answer any chat questions on space. So please join if you have the time, and thank you for watching this video. Bye.